Hi, welcome to video 3B, where we're going over Chapter 2's review. Again, I'm going to go over the Frappy. The PDF has more questions and answers. You can always request further than that. There is a textbook PDF, lots of information you could get. So don't forget, pause as you go along. And of course, kitties are awesome. General standard directions and access to a 15-minute relaxing timer if you want it. And I'm about to showcase each of the questions. So remember, you can pause and take screenshots or whatever you got to do, or you can open the PDF of this Frappy in the assignment itself. So here's the information, and then question A, question B, question C, and question D. All right, so now we're going to work through those solutions. Remember to give yourself an opportunity. If you want to do it part by part or just go through all 4 parts at once, it's up to you. But I highly recommend that you actually pause and think through these questions yourself, even if it's just, I don't quite remember this. That's okay, as long as you're thinking through it by yourself. All right, so the distribution of scores on a recent test closely follow a normal distribution with a mean of 22 points and a standard deviation of 4 points. What proportion of the students scored at least 25 points on this test? Cool. So some very important information is given to us. We're told it's a normal distribution. We have a mean value of 22 and a standard deviation of 4. Then they ask us, actually, let's just interpret that for just a second. So that means I can go ahead and sketch out a normal distribution. I can label the mean, and I can label as I need to the standard deviations at Z1, Z negative 1, Z2, negative 2, negative 3. So the question they're asking us is what proportion of the students scored at least 25. So what does that mean? It means that I need 25 or greater. That means I need the right tail of my normal distribution. So let's go ahead and draw out that normal distribution for ourselves. So here's the drawn format. I didn't label my Z1, Z2, Z3, but I know that 25 is larger than 22. I could have 22 plus 4 is 26, so that would be a Z-score of 1. So it's in between a Z-score of 0 and a Z-score of 1, a lot closer to 1. So I'm going to shade in the proportion that makes sense for us, 25 and greater. But I haven't finished. I haven't done the math itself. To finish this off, I'm going to have to convert my raw score of 25 points to my z-score. So I use my formula. I'm going to grab my laser pointer. So I use my formula of 25 minus 22. So the observed minus the expected over 4, the standard deviation or the error, and I get 0.75. Couple of major mistakes that can happen here, and I've listed one in our PowerPoint, and I thought of one other as well. So there's the first mistake is using that 0.75 the way it is. So I've highlighted where our answer is, but here's my be careful distracting. There could be people who could immediately just say, okay, 75%, there's my answer. If it was a multiple choice, I bet that would be one of our distracting answers. But more than that, the second distracting answer I can see would be if I recognize, hey, that's a z-score value, I need a proportion. So I actually have to go to table A or use my TI Nspire TI-84 calculator command. So if I go to table A and I go to 0.75 and I find my proportion value that matches that, it's actually 0.7734. There's the second mistake. I could see some people saying, okay, it's 77% or a 0.77 proportion. That's not true either, because that would mean from 0 to 25. That would be the other side, right? That left-hand tail where you're coming from less than or equal to 25. So you actually have to do 1 minus your table A and get the 20.2266 or 23%. So here's our answer. The proportion of students who scored at least 25 points is about 0.23. Another way of saying that is approximately 23% of students scored 25 points or higher on the recent test. Great. Let's move on to question B. But before we do that, there is a con practice. Woo, practice time. So you can practice calculating z-scores on this activity. So the distribution of scores on a recent, it's the same information from before. That's context. Question B. What is the 31st percentile of the distribution of test scores? Awesome, we're dealing with percentiles. If we don't recall, we can always practice, read through our textbook, whatever helps us out. I've got a con practice as well, but I'm just going to dive into this information. So 31st percentile means that if I think about my normal distribution as being 100%, then I just want that 31%. So I'm going to go ahead and draw it out. Ta-da! There's my Z, there's my normal distribution curve labeled correctly. There's 31%. And now I have to do the actual math. This is just a descriptor of it, and here is my math. So in the previous question, we looked at the z's on the columns and the rows, and we narrowed and converged down to a single proportion value. Now we're going backwards. We're looking at the proportion, and we're going to zoom out on our column and our row, and we're going to be looking for related to the proportion value 0.31. So I go to my table, I find the related z-score, and we ended up with negative 0.50. It really, if you're looking at table A, this is the value we use, 0.3085, because we didn't have 0.31. So you've got to find the one that's closest to it. If we plug that into our formula, where a z-score is equal to the observed minus the expected all over the standard deviation, then we can solve for an x value of 20. So we solved backwards to the raw score of 20 points on the exam. You can also, of course, use your TI calculator. If you use a calculator on a free response, you must include what you did. Just write the command into the FRQ. That's it. That's all you got to do, and then write it out. But if all you do is put your value raw score of 20, you don't get credit because nobody has any idea where you got it from. They just see a correct answer. So the 31st percentile is about 20 points. One quick thing, if they had asked for, nope, never mind. It doesn't work that way. Don't know what I was trying to think of. Okay, never mind. Let's move on to question C. Of course, here's your con practice, calculating percentiles. Now this time we're dealing with transformation. So this teacher decided to transform the mean to 80 points from our 22, the standard deviation to 10 points from our 4. She used a formula where we've got an A and a B that we have to solve. So let's break up that A and the B. A is a constant that's being added or subtracted. And remember, addition, subtraction for transformation of normal distributions only affects measures of center, mean and median. B, multiplication and division, affects measures of center and spread. So where do we still begin? How do I still solve? I've got two variables to solve for. Well, here's a big hint. Let's use our order of operations. If I plugged in my new score, 80 points, and I plugged in my old score, 22 points, looking at my two means and trying to get them there, what's the first thing that I would have to do? Well, I would have to first multiply before I added, because that's how order of operations work. So let's solve the multiplication first before we solve the constant addition subtraction. So starting with the multiplication, because adding a constant doesn't affect measures of spread. So all we're dealing right here is that standard deviation constant multiplication. So my new standard deviation is equal to b times the old standard deviation. So we're going to take 10 is equal to b times 4. So you can see where those values came from, and we simply end up with b is equal to 2.5. Cool. Now we have one of our variables. What's the difference to solve in that last variable? Nothing. You just plug and chug away. So we've got 80, which is the new mean that she wants to get to, 22, which is the old mean, 2.5 we just solved. Do a little bit of order of operations solving, and you get a is equal to 25. Ta-da, you have a new linear transformation. That's it. That's all you got to do for linear transformations. So a little bit of practice on transforming data right here. And our last question. This one's a little bit more of a, you got to think it through yourself. So before the test, the teacher gave a review assignment for homework. Max score was 10 points, mean of 9.2, standard deviation of 2.1. Would it be appropriate using a normal distribution to calculate the proportion of students who scored below 7 points? And of course, explain. Well, let's break that up into a little bit. We want to focus on a normal distribution, so why not try to create a normal distribution? So here's my normal curve. Pretty colors. I label my mean, and now I'm going to label a z of positive 1 and a z of negative 1. So I add 2.1, my standard error, to both my means, add and subtract, and I get my 2 z positive 1, z negative 1. Well, hold the phone. If they want to know that this is a normal distribution, can this even be possible? Can I have a z of positive 1 of 11.3? Can those be when the max score on this assignment was 10? This doesn't make sense for a normal distribution. So, if the distribution was normal, scores should go to at least 2 standard deviations above and below the mean. However, in this distribution, the highest possible is only a z of 0.38. So they calculated out what would happen if we dealt with the max score you could get. Therefore, it would be inappropriate to use normal distributions to do these calculations. You could have also seen it as, well, my mean value is super close to the max value. Immediately, you could have graphed that out and seen a skew that way as well. That's another way we could have calculated that out. And finally, there is a quiz that you could practice through with Khan, modeling data distributions. So let's go into our assignment. At this point, you can skim through the rest of the PDF for answers to the odd questions. You can email me for answers for the evens, or you can go ahead and jump into the assignment. Choose one of 3 options. Of course, you can always do more for additional practice. I will take submissions, grade them, blah, blah, blah. The best practice for you would be to solve one free response question, or you can solve 3 multiple choice questions, or you can send screenshots of your Khan work. Make sure you send each question. So I want to see your answer and whether you got it right, and then I want to see your final screen. So remember, this is a lot of images. Make sure to just throw them in a doc every time you screenshot, paste, screenshot, paste, screenshot, paste. Alrighty, that's all I got for you guys.